So today, guys, it's the last lesson of 7.7. It's only one lesson today. And then you're going to have the rest of the time to work on your review. And your test is not until Friday. Okay, so tomorrow is going to be another review day. Okay, so no lesson tomorrow, review day. And then your test is Friday. We're going to start 8182 on Thursday. Sounds good? Okay, good, excellent. Okay, oh, I think I have a message. Can someone read it to me? What did somebody say in the comment?
They just said, yeah.
Oh, perfect, beautiful. Okay, so recall from yesterday. So we did the cross product yesterday. And we learned that when you take the cross product, it gives you a vector that is perpendicular to both of the vectors that you're crossing. We learned that you can have any scalar multiple multiplied by that in the same direction. Yes, so there's an infinite number of perpendicular vectors that will be perpendicular to those two vectors that you are crossing. We also learned that those two vectors can form a parallelogram. And if you take the cross product and then you take the magnitude of those components, then what you're finding is the area of the parallelogram. Okay, so here we're going to see why. It's very simple. As you can see, I've drawn a right angle triangle. So I can say here the area is equal to base times height. So I can say that's equal to the magnitude of u times the height. Yes, both scalars. Well, what's the height equal to? If I come up with an expression.
Magnitude of v sine theta.
Excellent, good. And it comes from SOHCAHTOA, right? So sine of theta is equal to opposite over hypotenuse, and then you rearrange it, and you're absolutely right. You are going to get okay. Well, what's this equal to? Does this look familiar? You should look familiar.
Cross product.
Yeah, good. This was the geometric formula for the cross product. The magnitude of it, right? Okay. And so there's your proof right there. And again, guys, for sine of theta, I didn't finish it here. It's just equal to opposite over hypotenuse. And then you can go ahead and rearrange from here. Okay, and that's how we get that h is equal to magnitude of v times sine of theta. Okay, so furthermore, and I kind of mentioned this yesterday, if I want to find the area of the triangle formed by these two vectors, then I'm just going to take half of that result. Because as you can see, here's my vector A, here's my vector B, there's my resultant, it forms a triangle, and it is half of the area of the parallelogram. Cool? So that means it would be half of the magnitude of your cross product. Right, because this is just your area of parallelogram. My shorthand. Okay. Furthermore, here we have the volume of a 3D parallelogram. So we're calling this a parallelepiped. Okay, parallelepiped. 3D parallelogram. And the volume, just like with any other 3D figure, is the area of the base times the height. So depending on how you draw this, because we can move this to have very different bases, right? Depends on what side we have this parallelepiped on. It could be this, vector A, dotted with the cross product of vectors B and C. Or it could be vector B dotted with a cross product C. Or the case that I'm showing is vector C dotted with A cross B. Okay, so depending on what you have as your base. So my base are the vectors A and B. And so I'm dotting C with the vector that is perpendicular. Okay, so A cross B. Okay. Sorry guys, give me 1 sec, okay? Hold on. Yeah, I heard. Yeah. Okay, I'm back. All right, and the proof is here. If you guys want to take a look at the proof of that, it's here. Okay, and again, it's not a difficult proof. It has to do with the scalar projection of C onto B. Sorry, C onto A cross B, okay, which is your perpendicular vector. So I'll highlight it for you right here. Okay, so the projection and the projection stops. Cool. All right. And again, guys, you're not responsible for knowing the proofs, okay? All right. Are there any questions so far? Okay. Keeping moving along. Example 1. So determine the area of a triangle with vertices A, B, and C. We're given the components. So what should I do? I just have all I have here, sorry, they're just points. All I have are points. So I'm given the vertices of my triangle. So what do I need to do? Sorry guys, give me 1 second.
The whole steel shape.
Sorry.
Whole bracket shape.
The whole bracket.
Yeah. I'll talk to someone later. Okay.
Okay. You know what you're doing. Okay, so sorry guys. Determine the area of a triangle with vertices A, B, and C. So I have the vertices. I want to find the area of the triangle. We know that if I find the vectors that create this parallelogram, right? So if I find two vectors that can make the parallelogram and I take half of it, then that's the area of the triangle. So how can I come up with some vectors here? What can I do?
A, B, and AC.
Yeah, you could do A, B, and AC. So if I want to find vector AB, and Be very careful here, guys, because this was a common error on the test. If you're finding vector AB, I'm not doing A minus B, I'm doing vector B minus vector A. Okay, so be very careful. So what would my components be? Vector B minus vector A.
5,
Yeah, go
negative
for it.
1,
Yeah,
and negative 4.
perfect. Okay, so now I can call this vector U, okay, or vector AB. I'm just saying U because that's how you learn the formula. So just so you can see that that's one side of my parallelogram or of my triangle as well. Okay, so now I'm going to find vector AC.
Wait, miss, for this question,
Yeah.
it doesn't matter if it's ABAC or BABC or CACB,
Doesn't matter.
right? Okay.
Nope, doesn't matter. So, where was I? AC. So C minus A. So what do I get?
2,
Mm-hmm.
0, and negative 5.
Good, and I'll call that V. So now I have two sides of my parallelogram, right? And I know that half of this is going to give me the area of the triangle. So what I want to do first is cross U and V, right? And if you guys remember to cross U and V, I'm just going to actually move this down. What do I do to cross U and V? What's my shortcut?
We put the components of vector AB 2 times, and then on the next line, we put the components of vector AC 2 times.
Perfect. Does it matter which vector I write first?
No.
Yes. What happens if I write it the other way? I'm not saying in this particular case. I'm saying in general.
We'll get the opposite direction.
Good. Excellent. So we don't worry about those two. Good. Okay, so we're going to cross these. So what do I get? Nobody wants to do this? So -1 times -5 is 5. And then I'm subtracting 0 times -4, which is 0. And then I have -8 minus -25. And then I have 0 minus -2. Okay, so I have my cross product. And now I want what?
Half the magnitude of that.
Yeah, I want half the magnitude. Good, to get the triangle. I'm just going to do the magnitude just to find the area of the parallelogram first. And we know that we take the sum of the squares and then take the square root. So what do I get here? When I add these, the sum of the squares, what do I get?
Root 318.
Good. Perfect. And this is area of parallelogram. Oops. Which is also base times height. All right. So now for area of a triangle, I need half base times height. And so I need half of the square root of 318. What do you get? One decimal place. How many units squared? How many square units?
8.9. Sorry.
That's okay. I'd rather have 2 than none answer. So 8.9 square units. Okay, pretty simple, guys. Pretty straightforward. Nothing tricky here, right? Okay, example 2. Find the volume of the parallelepiped determined by these vectors. So now I have vectors and we want to know the volume. So it's my formula. And it doesn't matter which way I do this. Remember 3 forms of this formula? Does it matter? Does it matter what I use as my base? No, it doesn't matter. Very good. Okay, so I need to have the cross product of B and C. So let's do that first. So I have B first, 4, 0, 1, 4, 0, 1. Oops, I should have left a little more space there. And then I have negative 1, negative 1. And so then I see that the cross product of B and C is equal to what? 0 plus 1, 3 plus 4, negative 4 minus 0. -7, -4. Okay, and now you just sub into the formula, simple dot product. There's my A, right? A dotted with B cross C. And so when I do my dot product, how do I do this? And of course, I want the magnitude. What am I doing here?
Multiply the components.
Good. So, for example, 2.
Times 1.
Yep,
Plus negative
and then?
5 times 7 plus
Good.
negative 1 times negative 4.
Good. And so I get the magnitude of negative 29, but we know that it's positive. And there's your volume. Cool. Any questions or still pretty straightforward? Okay, let's keep going. Okay, so now we're back to forces. We're going to talk about work. And you should already know what work is because when we learned the dot product, we defined work, didn't we? So let's take a look. It says here, when a force is acting on an object so that the object is moved from one point to another, okay, so there's the displacement, it's being moved, we say that the force has done work. Well, if you look at that definition, that's the same definition of the dot product. And so in order to find the work done, then we're going to dot the force in newtons and the displacement in meters. Okay, and that's how you're going to find how much work is done. Work is a scalar quantity and is measured in joules. Work can be negative, and friction is an example of this, of work being negative, because friction is always in the opposite direction, right? Does everyone know what friction is?
Yes.
Yeah.
Yes? Okay, good. Excellent. Okay, good. Any questions so far? Also, work we measure in joules, but work can also be measured in?
Newton meters.
Watt?
Yeah, Newton meters. So joules and Newton meters are the same, yes? But as far as I know, I'm not a physics person, but as far as I know, we prefer to use joules. Okay? All right. So example 3. A worker is pulling a crate 140 centimeters and exerting a force of 147 newtons using a rope which is forming an angle of 15 degrees with the horizontal. How much work was done? Okay, so I have my rope. And so how can I label this? What does this dashed vector represent? Or this dashed arrow? What does it represent?
The force.
It's the force. Excellent. It's your force. And so we see that the force is 147 newtons. Good. We know now that it's being displaced. The crate is moving 140 centimeters. And it's moving this way, correct? So there's my 140 centimeters. And so this is my displacement vector. Okay, it's being moved to the right, 140 centimeters. And now we just have to use the formula. It's as simple as that. So work is equal to force dotted with your displacement. And in a case like this, which formula do I need to use for the dot product? Geometric or algebraic?
Geometric.
Yes, very good. I'm not given components here. What else needs to be labeled on my diagram? What did I miss?
The angle made.
Very good. So we have a rope which is forming an angle of 15 degrees with the horizontal. Okay. Good. And now we just sub in.
Miss,
Yeah,
do we have to convert the centimeters to meters?
you do. Very good. Excellent. So our displacement is 140 centimeters, but we need it to be in meters. And so what is the equivalent?
1.4 meters.
Excellent. And I'll highlight that above because I didn't. In meters. Force in newtons. And that's why they're called Newton meters. Okay. But we use joules. Yes? Okay. Okay. I need my pen. All right. And then cos of 15. Uh-oh. What did I do that's not good here? We're in math, we never put our units in. I don't want my units there. That's what our statement is for. All right. And cos of 15. There you go. And now just approximate it to 1 decimal place, please.
198.8.
Good. Therefore, the work done is, come on, 198.8 joules. Are there any questions? Very simple. And I'm going to be honest with you guys, when it comes to work and even torque, we're going to talk about torque next. The questions you get are very simple. They're not going to be complicated. They're not going to be tricky. They are just to understand the concept, just to use the formula. They're not going to be anything crazy. Okay. Keep in mind, guys, here that we are using the geometric equation for the dot product. Okay. Good. Uh-oh. Sorry. That erased. There we go. Okay, so let's talk about torque. I'm sure everyone has heard this word. I know that as a kid, I remember hearing the word torque with reference to a car. Okay, so what is torque? Torque is rotational or turning effect about a point A, created by a force acting on an object located at another point B, and it is given by your cross product. So let's understand this. So I think the easiest example to look at is that of a wrench. Another good example to think about is hinges on a door, like a door opening and closing, because it's a rotational force, right? So when we think of a wrench, when you hold a wrench and then you pull that you pull that lever down, it's a rotational force, right? There's an angle that's being formed there. Okay. So torque is a vector quantity caused by a force in newtons at a distance of r in meters from the center of rotation. The magnitude of the torque measures the twisting effect of the applied force. So there's your rotation. It's the twisting effect, okay? How strong the turn is, and is measured in Newton meters. So let's take a look at an example. So here it says a 40 Newton force is applied to a 15 centimeter wrench, which makes an angle of 20 degrees with the handle. What is the magnitude of the torque on the bolt at the other end of the wrench? So what I want you guys to do is, I want you guys to try labeling this. And I just have my daughter who has a question, and I will be right back in 1 sec. So try to label that diagram. Okay, guys, can I ask you a question? Because you guys will probably know better than me. In Google Slides, if you're using an iPad, and you have to edit a file, let's say, or your Google Slides, whatever it is, once you save it, is there any way to go back and edit what you've already saved, or do you have to go back to the blank document again? Does
Is this
anyone
for
know?
slides?
I'm sorry?
Is this for slides?
It's for slides. It's for slides. So my daughter's writing a test and she needs, so what happened was she saved it and she probably shouldn't have, because now she can't go back and erase anything. I mean, at least we don't know how. So that's what I'm asking. Is there a way to go back and erase once you've saved?
I'm not sure for tests, but normally in slides you can go to like edited versions and you can see like different versions from where you saved.
So yes, so we did that. Very good. So we did. We went into an edited version, but on that edited version, she needs to erase something now, but it's already been saved. She can't do that, can she?
Try double tapping on the box that she needs to write in.
Double tapping on the box. Okay, I'm gonna tell her. Sorry guys, just give me 1 sec. I'll be right back. Okay, no, unfortunately, it's not working because it's an iPad, so she's using the pen feature. Anyways, it's fine. It's just gonna be messy. Okay. How are you guys doing? Let's go back. All right, so here we had a wrench, 40 Newton force is being applied. Okay, so when I turn this wrench, right, when I turn this wrench, I'm turning it downwards, and so this is my force. And we're told that the wrench is 15 centimeters long. Okay. And we're told it makes an angle of 20 degrees with the handle. The 40 Newton force. Good. So here's my force, and we know that it equals 40 newtons. Okay. Was everyone able to do that?
Yep.
Good. Excellent. Okay, so now I want to find the torque. And so all I have to do is plug into the formula. Okay, and notice, guys, that I'm taking the magnitude because torque is a force, right? Torque is a vector. Okay, all right, so doing the cross product. Again, I'm going to be using the geometric form of my cross product because we're talking about an angle, right? We're dealing with a triangle here. We're not dealing with components. And you just have to sub in. So can I sub in 15 centimeters?
No.
No, good. It has to be in meters. And so I have to make sure to convert, okay? So just be careful there. Force is fine. And that's it. Tell me approximate, please, what the torque is.
Uh, 2.05.
Good. Let's say 2.1. Let's say therefore, the torque is approximately 2.1 Newton meters. Cool.
Wait,
And
miss,
like I said, guys, yeah, tell me.
why is the angle 20 degrees instead of
It was-
160?
It was
Because-
given.
Is it because like the 15 centimeters, it goes away from it, the vector, I guess?
It's telling us a 40 Newton force is applied to a 15 centimeter wrench, which makes an angle. The force makes an angle of 20 degrees with the handle.
Okay,
Do you see that?
thanks. Yeah,
Yeah, no problem.
thanks.
Yeah, no worries. So all that we did here was we extended this line, right, which is the wrench, which is technically our horizontal, and then we made 20 degrees. Okay, and this is your homework, guys. So page 415, 2 to 3, 5 to 9, omit 3A. Page 14, numbers 1 to 30, 31A and 34 is your review. For 1C, let's see the notes here. It says multiplication because they are scalars. I'm not sure what that's referring to. I have to go back to the book, but I'm sure it will make sense to you when you're doing your work. Number 8, vectors from sides, not from the diagonal. So it's clarification. Number 14, answer should be negative 5.5. And 17A and 17C, I'm not sure what's going on there. Let's see if I have a note here. I don't. Anyways, you guys get started and I'll see what's going on here. It could just be that there's an incorrect answer.